Hello and welcome to Vaslav's Maths tutorial. I'm going to do a question from C3 past exam in June 2012, question 3. You've been given a graph of a function y is equal to e to the x root 3 sine 3x in a range x between minus pi over 3 and pi over 3, and you've been asked to find the coordinate x coordinate of the turning point P in terms of pi. Okay, a little bit of a theory. You should know that the at the turning point the derivative of the curve is equal to 0, so we need to differentiate the function. I've written and done some of the question beforehand to save us time. I've rewritten the function here, y is equal to e to the x root 3 sine 3x, and if we take the first term to be v, e to the x root 3v, and the next term sine 3x as u, then we would have y is equal to vu. Then if I differentiate using chain rule, the derivative of the function is equal to v dash u plus vu dash. Okay, so I've repeated that here. Remember, divide the x is equal to that. So let's go back and find the derivatives separately. V is equal to e to the x root 3, so therefore v dash must be the derivative of whatever is at the top here, which is root 3, and derivative of x obviously is 1, so root 3 e to the f of x, whatever the function is, so you just put that there, and that's the derivative of the v. Derivative of u is the derivative of this bit, which is 3, comes out first, then the derivative of sine is cos, so it's going to be cos 3x. So let's go back and plug this in to the original equation. So okay, so dx is equal to v dash, we got it here, and that's v dash, and that's u, and plus then v, and that's u dash. Okay, so now we know that the derivative is equal to 0, so we have to set the derivative equal to 0. If I just factorize e to the x root 3, because it's in common in both of them, then I'm just going to get root 3 sine 3x plus 3 cos 3x, and set it equal to 0 because derivative at point P is equal to 0. Okay, divide dx. So, but I know that e to the x root 3 is always positive exponential function. Remember, cannot be 0, bigger than 0 for whatever value of x. So that cannot be 0. So what can be 0? So this expression must be 0. So I can say root 3 sine 3x plus 3 cos 3x must be equal to 0. Basically, now we have to solve this trigonometric equation. Best things to do, as we can see, when we got sine and a cos in a trig equation, we need to divide by cos to get tan. That's the easiest. So let's divide everything by root 3 cos 3x. So we do that, root 3 cos 3x, do the same here, root 3 cos 3x. Okay, so from here that cancels out, so I get tan 3x plus that one, and that cos cancels out there as well. I get 3 divided by root 3 is equal to 0, and then further we can say tan 3x must be equal to minus 3 root 3, rationalizing the denominator, minus 3 root 3 times root 3. So further we can say tan 3x is equal to minus 3 root 3 at the top, and at the bottom I get 3. It cancels out. I get minus root 3, and that gives me 3. Yeah, if you use your calculator, realize that's going to be minus 60, but let's present it in terms of pi, which is minus pi divided by 3. But remember, it's a negative value of x. We don't want that, so we want the next value, since tan is periodic, by pi. So the next solution should be minus pi divided by 3 plus pi, and from that we're going to get 2 pi divided by 3. So you're going to say that 3x must be equal to then 2 pi divided by 3. So from here, x is equal to 2 pi divided by 9. Okay, so the x coordinates of p becomes equal to 2 pi divided by 9. Okay, part B is asking you to find the equation of a normal at x equal to 0. Whenever you've been asked to work out an equation of a normal, first you need to work out the gradient of the tangent first, because the gradient of the tangent is equal to the derivative of the function at that point. So let's go back to the derivative. And put x is equal. Okay, this is the derivative here, if you remember, and then we need to put 0 in there for x. We can say dy dx, if I remember correctly, was equal to e to the x root 3 sine 3x plus 3 cos 3x at x equal to 0. So we need to work out the derivative at x equal to 0. Substitute that 0 for x, so we can get root 3 sine 0 plus 3 cos 0, because x is 0. Okay, and further, e to the power of 0 is 1, and root 3 sine 0 is 0, so that's 0, plus cos of 0 is 1, so we get 3. So therefore we can see that dy dx must equal to 3 times 1, 3. Okay, so this is the m of the tangent, which is equal to 3. It's the same as the derivative. So the m of normal, it's minus 1 over 3. Remember, since mn times mt is equal to minus 1, I'll leave that for you to work out, to look at. So now that I've got the gradient of the normal, then I can write its equation. General equation of a line, y minus y1 is equal to m of the normal x minus x1. So x, we want to write the equation of normal at x equal to 0. Remember, we've been asked to do, and when x is equal to 0, we have to go and find the corresponding y value in the original equation. So if you look at the original equation, we can see that okay, I've written the original question here. Y is equal to e to the x root 3 sine 3x. So when x is equal to 0, we want to work out the corresponding y value. So y also becomes equal to 0. So we want to write the equation of the normal at that point, and that point, remember, is the origin. So we do that. Y minus 0, remember that one, y1 is equal to the gradient of the normal minus a third, and then x minus x1 here Remember, this is x1 and this is y1. It's equal to 0, so therefore y is equal to minus 1/3 of x. That would be the equation of the normal. Thank you.